If you know your quadrantal angles and quadrant 1, you don't need to have the whole unit circle memorized. As long as you remember how to use reference angles and how to draw angles. And this is all stuff that we did in 10.1 and 10.2. So if you understood all of that, we should be in pretty good shape. I'm going to do some of the angle measures that are on the unit circle, and we're going to begin evaluating them. So the first thing we're going to do is evaluate sine of 120. Now before I do this, we need to keep in mind what sine, cosine, tangent represent, cosecant, secant, cotangent. We know that sine, cosine, and tangent, we use SOHCAHTOA, which stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Well, in the unit circle, we know that the hypotenuse is always 1. And also, we know that the opposite, if we take a look at it, opposite to the theta is always the y value, adjacent to the theta is always the x value. So I'll say that again, the hypotenuse is always 1, opposite to theta is always the y value, adjacent is always the x value. So maybe it would even help if I scroll back down here and we draw a picture of it. If this is my theta, oops, let me squish over a little bit. In the unit circle, the hypotenuse is always 1. The opposite is my y value, and the adjacent is my x value. So sine, if it's opposite over hypotenuse, sine is equivalent to the y value over 1, or that's just y. Cosecant, remember, is the reciprocal of sine. So the reciprocal of y over 1 is 1 over y. Cosine is always adjacent over hypotenuse. So that's going to be x over 1, or just x. Secant is the reciprocal of cosine, so the reciprocal of x over 1 is 1 over x. And lastly, tangent is always opposite over adjacent, so that would be the y value over the x value. And with cotangent being the reciprocal of tangent, that would make it x over y. So we're going to use these ideas about our values and the trig functions in order to evaluate. So now we're back to actually evaluating sine of 120. The first thing that I would like you to do is sketch a 120 degree angle. So I'm just going to draw my coordinate plane and label my quadrantal angles. So 0, 90, 180, 270, 360. When we draw our angles, we always start in standard position. So this is my initial side. If I have a positive theta, I'm going to rotate in a counterclockwise rotation. If I have a negative theta, I'd go in a clockwise rotation. Because I have a positive 120, I'm going to go in a counterclockwise rotation. So I'm going to start at 0. I'm going to go in this direction. I'm going to pass the 90. Now 120 is pretty close to 90 degrees, so I don't want to draw it too far or too close to the 180. I want to stay right around here. You want to make sure that your picture actually represents the degree it's looking for, and I think 120 is right about here. So that's my theta. There's a couple of questions that I'm going to ask you in order to help us get to the point where we can evaluate sine of 120. So the first thing I want to know is, what quadrant did the terminal side land in? And that would be quadrant 2. The reason why I want to know this is because we just learned at the top of this page that each quadrant has different signs. Because we landed in quadrant 2, I know that the x value will be negative and the y value will be positive. That's why it's so important. Now, the next thing I want to know is what value from the coordinate are we going to look at? So if I would like to know what sine is, I'm going to scroll up. We just talked about it here. Sine is equivalent to the y value. So I would like to know what the y value of the coordinate is. And if I know that I want the y value, I can look at what quadrant it's in and say if it's going to be positive or negative. So the y value in the second quadrant will be positive. Okay. Now I need to determine what the reference angle is. So we're going to go back up to our picture. And to draw my right triangle that I'm interested in, I'm going to take a point on my my terminal side and drop it to the x-axis. So I've just created a special right triangle, but I need to know what type of special right triangle did I create. We knew that theta was 120 degrees. Since it's in quadrant 2, we've learned earlier that theta prime is equivalent to 180 minus theta. So 180 minus 120 gives me 60 degrees. So I have a 60-degree reference angle. The reason why that's so important that I'm able to distinguish that is because now I can assign the values of my special right triangle. My 60 degrees is right here, so opposite to that would be my longest leg of root 3 over 2. And because that's the y value, I know it's going to be positive. The shortest leg is going to be 1/2. But it's going to be a negative 1/2 because I'm in the second quadrant, or the x value is going to the left, which is a negative movement. So finally, we're ready to answer. I said that I wanted to know the positive y value in order to answer what is sine of 120. So sine of 120, if I look at it, the y value is a positive root 3 over 2. So root 3 over 2. That's my final answer. That's what we were working towards. All right, let's take a look at the next one. First thing that I'd like you to do is sketch the angle. So I'm just going to label the generic. It's 0, pi over 2, pi, 3 pi over 2, 2 pi. Then we could look at the denominator and rewrite it, but in this case I don't have to because I already have a 3 pi over 2 right here. So if I'm going to draw the angle, I start at my initial side, and because it was positive, I'm going to rotate in a counterclockwise rotation, and my terminal side will be right here along the negative y-axis. So when it asks what quadrant it's in, really it's in between quadrant 2 and 3. So I'm just gonna kind of, I guess I'm gonna go like this. I'm gonna kind of group 3 and 4 together and write quadrantal angle because it separates quadrant 3, quadrant 4. And then when it says value from the coordinate, so this time I'm evaluating cosine of 3 pi over 2. If sine was the y value, cosine is going to be the x value. So the x value is going to be, I have to determine positive or negative. Well, the good thing is you should already know the coordinate of your quadrantal angles. I know that this coordinate right here is 0, -1. So because I've moved down, and I didn't move left or right, when it says sine, I mean, the x value is 0, so that's not that's not really positive or negative, so I'm just going to put not applicable. What is the reference angle? Well, we don't have a special right triangle. It's just a quadrantal angle, which we already knew the coordinate of. So when it says, what is cosine of 3 pi over 2? Cosine, the x value is 0. Now, I know there's not an example on here, but I just want to show you tangent. So let's say I wanted tangent of 3 pi over 2. Tangent is not the x value or the y value. It's the y value over the x value. So in the the 3 pi over 2, there we go, the y value was -1, the x value was 0. So tangent is -1 over 0. But we can't divide a number by 0, so tangent is actually undefined for 3 pi over 2. We're going to practice tangent once more. We're going to go back over here to the 120-degree angle. So if I would have asked you what tangent of 120 would have been, once again, it's the y value over the x value. So the y value was √3 over 2 over the x value, which was -1/2. If you have something like this, a fraction divided by a fraction, remember you do keep, change, flip. So √3 over 2 times a -2 over 1. The 2's cancel, and I'm left with a -√3. So that would be the value of tangent. And keep in mind, had the √3 ended up in the denominator, you would have to rationalize that expression.